Alright guys, we're going to do some quotient rule today, dividing powers that have the same base. When we found out through our notes that when you divide powers that have the same base, a shortcut is to subtract the exponents, and that's really the rule we want to follow. We can do it the long way, but this rule helps us go things quicker. This first one, you can tell we got 4 to the 5th divided by 4 to the 3rd. They do have, it is 2 powers, and they both have the same base of 4, so I'm just going to subtract exponents. Here we go, subtract exponents. And when I do that, 5 minus 3, of course, is 2. And then, of course, I simplify 4 squared is 16. Okay? A longer way of doing that, now that's the shortcut, and that's the way we want to do things. But if you forget what 4 to the 5th is, oh, sorry, it's numerical. I forgot how I did this. It is numerical. If I needed to, since it's numerical, I could have just done 4 to the 5th power, and you can put it in your calculator, it's 1024. And I could have done 4 to the 3rd power, which is 64, and then I could have divided 1024 divided by 64 and gotten 16. It's the same thing, and that's the whole point, is that it's the same. On the bottom, of course, I've got variables, so I'm going to have to follow my rules here. So I follow the rules. I do x to the 6th, subtract, so I do 6 minus 8. Of course, 6 minus 8 is negative 2, and I'm not allowed to leave negative exponents in a simplified answer. So I do the reciprocal of negative 2, and I get 1 over x squared, and that's the simple way. Now I'm going to show you the longer way as well. I'm just going to define what x to the 6th means. Of course it means I got 6 x's, right? And x to the 8th would mean I have 8 x's. And what happens is if I can divide those out, and you can see this 1, you know, these divide out, so they're gone. And I'm left with 2 x's. And where are those 2 x's? They're in the denominator. So hopefully you can see that those are actually the same thing. Another example or two as we look at these. I've got 5 over 15 here. I'm just going to simplify that. Okay, 5 over 15 is just a fraction. It reduces down to 1/3. Now I can deal with the x, and my rule is if I have the same base, if I'm dividing with the same base, I can subtract the exponents. So I'm going to subtract 3 minus negative 4. And of course 3 minus negative 4, following my rules, that changes to positive 7. And I'm actually good to stop right there. But sometimes people don't like this answer. They don't like it written as 1/3 as a coefficient. So I also need to be prepared to write it as one big fraction together. Okay? And the reason it's one big fraction together like that is, if you'll notice, this x to the 7th is really x to the 7th over 1. So x to the 7th goes in the numerator. 3, of course, is already in the denominator. It stays down there. Both of those are the same. Okay. Last example for you real quick. Just kind of flipping through. I've got multiple power rules all jumbled up together. You'll notice on the inside of the parentheses here, I actually have some simplifying I can do. So let's just follow the order of operations. Do 2 divided by 4. Of course, that's 1/2. Now, this a right here does have an exponent. It's a 1, so I'm going to do 1 minus 5. And 1 minus 5 gives me a to the negative 4. Now, I'm going to go ahead and clean that up. Oh, not yet. I'll clean it up in a minute. I'm good to go ahead and deal with this power now, this x to the 3rd. And what goes to the 3rd power? Well, both of these terms get a 3rd power. So I've got 1/2.
This is just a reminder from Mandy. Timekeeper is down, and if you're not able to sign out, please email Mandy your sign out time.
Yeah, what I did here is I went ahead and I did clean up the a to the negative 4. I went ahead and did the reciprocal of it, made it 1 over 2a to the 4th. Now it's going to be easier to deal with this third power. So the third power goes to everything. So 1 to the third on top, 2 to the third goes on the bottom, and then I have a power rule I have to follow. When I have a power raised to a power, a to the 4th and then raised to the 3rd again, it's actually going to be a to the 12th. Okay? Now, I could have gone about this a different way. If you didn't want to deal with the parentheses first, you could have actually gone ahead and multiplied the power of 3, and everything in here would have had a power of 3, but generally that just makes things more complicated. I'll let you watch through this. I'm not going to explain it, though. You can do either one of these methods. Take a moment here to pause, make sure you know where the third powers came from. And then you start simplifying. And notice they're the same. Guys, watch this as often as you need to, and send me an email if you have any questions.